In lesson 1, we talked about the multiplication properties of exponents, and today we're going to take a look at the division properties of exponents. So we're in lesson 8-2. When we talked about multiplication, as long as they had the same base, we would add the exponents. So it's the opposite with division. We're going to subtract the exponents. So if we have 2 to the 8th power over 2 to the 3rd power, remember fraction bar means divide, we can subtract those exponents. 8 minus 3 is 5, so we end up with 2 to the 5th power. Same when it's a variable. So r to the 5th over r to the 4th. You're going to take the top of the fraction, take that exponent, and subtract down. So 5 minus 4 is 1. We just write r. So you can see in the key concept box, we have the quotient of powers property. Probably a good thing to add to your notes. Example 1. We're going to simplify. Notice on this example we have B's and C's, and the process of being able to simplify this is to break it down. So we're going to start with the B's. So we have B to the 5th over B to the 2nd, and then we have C to the 7th over C. Remember, it has to have the same base, so that's why we're separating these. So we're going to take B to the 5th minus 2, and C to the 7th minus 1. So we get B to the 3rd times C to the 6th. So again, that's subtraction when it comes to dividing. Take a look at the check. Notice on the top of the fraction there's an a squared, but there is no a on the bottom of the fraction. So a squared stays as it is. Then I'm going to look at the b's. I have a b to the 9th over b to the 8th. 9 minus 8 is 1, so just b. The c's are both 1. 1 minus 1 is 0. Remember, anything to the 0 power is just the whole number 1, not c to the 1, just 1. It's kind of like c over c equals 1, or like 5 over 5 equals 1, not c to the 1, just 1. But because we already have a squared and b, we don't need to write the 1 for a coefficient. So it's like these c's just cancel each other out. And then, of course, with d, we have d to the 4th over d. So 4 minus 1 is 3, so d cubed. So we would have d as our answer. Moving on to example 2. At sea level, there are about 10 to the 25 molecules in a cubic liter of air. In the stratosphere, about 30 kilometers above the Earth's surface, the same cubic liter of air has about 10 to the 23 molecules. Approximately how many times as many molecules are there in a cubic liter of air at sea level as there are in the stratosphere? Keywords being how many times as many. So if I have 10 and you have 30, you have 3 times as many as I do. So we're going to divide. 30 divided by 10 is 3. So same thing here, we're going to use division. So we have 10 to the 25th power over 10 to the 23rd power, and of course use that subtraction. So 10 to the 25 minus 23 is 10 squared, and of course 10 squared is 100, so about 100 times as many molecules. Same thing in the check. So we have 3 to the 9th power parking spaces in one parking garage, and then we have 3 to the 8th in the other. And again, we're just going to find how many times as many. So division, 3 to the 9th over 3 to the 8th. Subtract, and we get 3 to the 1, or just 3. So again, that division, we're going to subtract those exponents. Just like we talked about in multiplication, we can also have a power of a quotient. So when we have 2 to the 5th to the 3rd power, we have to take that power to both pieces of the fraction, keeping them on the proper side of the fraction bar. So the 2 to the 3rd stays at the top, the 5 to the 3rd stays at the bottom of the fraction. But again, because to the 3rd power means we're going to have those 3 factors 3 times, we have to do both the 2 and the 5. So then again with p and p over q, p squared over q squared. So we end up with taking that power to both things. Now remember, if it already has an exponent, like let's say this, then we take the power to the power, which means we're going to multiply. This one is like a 1, so it's q squared. So again, following those same properties that we talked about with multiplication. So again, there's that property, power of a quotient. Great thing to add to your notes. Anytime you see the key concept, add that into your notes. So example 3, again, this third power is going to all 3 parts inside the parentheses. So we're going to take 5 to the third power, which is 125. We're going to take a squared to the third power. Remember, multiply the exponents. And then we're also going to take 6 to the third power, which is 216. Notice everything stayed on its side of the fraction bar when we did the power. So then the check, same thing here. We're going to take 5 to the fourth power, which is 625. J to the third to the fourth power, multiply and get 12. L squared to the fourth power, multiply and get 8, over 7 to the fourth power, 2,401, and k to the fifth to the fourth power, k to the 20. So what we got there, B for the check. Example 4, you'll notice that they chose to take the powers first and then do simplification. So the top of the fraction has both x's and y's as well as the bottom. What I would choose to do is simplify first before I take the exponent. So this in parentheses is squared, but we know according to order of operations, we can do the parentheses first. So if I was going to do this problem, I would do the simplifying first and then square it. So x to the fourth over x to the 1 would be x to the third. Y over y is going to cancel out. There's no z on the top, so the z stays on the bottom. And then if I square that, I get x to the 6, square that z squared, which notice is the same thing they got. They chose to do the square part first, so they took that square to each piece and then simplified. Either way works. Notice it's the same regardless. Now on this example, they're asking us to use justification for each step. So basically, what property was used to get to the next step? So our first step is power of a quotient, because we have that fraction being taken to the second power. And then the second one is where we're actually taking power of a product. So we have a product, we're multiplying the x to the 4 times y, and we're going to take the power. So power of a product. Step 3 then is we're taking that power to that power. So power of a power. And then that last step is the quotient of powers, that first thing we talked about. And just remember, all of these powers are definitely things that you would want to have in your notes, because this is different properties that you need to know for algebra. So good things to add to your notes there. Take a look at the check. Whoops, still have it circled there. And again, I would look to simplify first. So the numbers are 4/3. I can't simplify 4/3. It's going to stay 4/3. But if it was 6/3 or something like that, you could simplify the fraction, just like treat it like a fraction, like you're reducing. And then the m's, they have the m squared and the m to, remember, no number means to the 1. So 2 minus 1 is 1. N squared is on its own. There's no n on the bottom, so it's going to stay on the top. P squared over p, 2 minus 1 is 1. So we end up with that. Remember, we're taking this to the 4th power now. So first we're going to do 4 to the 4th power, which is 256. M to the 4th power, n squared to the 4th power, n to the 8, and then p to the 4th power. And then that last one is taking that 3 to the 4th power to get 81. So what do we got? C there, I think, matches up. Okay, so again, we're using multiple different properties there to solve. And again, you could have chosen to take the 4 to all of the pieces first and then simplified, whatever works better for you. Okay, so then for the homework, we're going to do 2 through 30 for the evens. Again, follow those same process and follow your, go back to your examples and check if you get stuck. I do want to do number 20 with you just because it is a little bit of a review from when you learned about circles. So number 20 says write the ratio. Remember, ratio comparing two amounts, and we'll write this ratio as a fraction, hence the division we've been talking about. So the ratio of the area of a circle with a radius r to the circumference of that same circle. So remember, area of a circle is pi times radius squared, and the circumference of a circle is pi times diameter, but we can write diameter in terms of radius. It's just 2 times the radius equals the diameter. So instead of pi times d, I'm going to do 2 times pi times r and put that 2 in front just to act as that coefficient. And then our pi's cancel out, and then r squared over r, we're going to subtract 2 minus 1, so we get r over 2 for our final fraction. Number 22 is going to be very similar to what we did in the other story problems. Remember that how many times more means we're doing that division, so that's how you're going to do that. And again, then you'll carry on and do the next page as well. So that is lesson 8-2. Again, 2 through 30 for the evens.